Our presenter today is Jason Bramer. He's one of our variation analysts here at DCS. He's also our CATIA specialist. Jason does a lot of work with our IT support, so if you've sent in an email or you've called in to get some assistance with your 3DCS software, you've probably had a chance to speak with Jason. So he's very knowledgeable about the software, and I'm excited to have him here with us today. Before we get into the actual demonstration, showing you these great new features and the updates to them, I do want to make note that in your interface on the right-hand side, you've got a questions box. Please feel free to send your questions in throughout the event and as they come up. So that way we can try to either get to them while we're talking about that particular topic, and if we're not able to get to them right away, we will have a Q&A session at the end. Today's event is going to be about 30 minutes. We're going to leave 15 to 20 minutes at the end for a total of 50 minutes today. If you want to stay on afterwards, we're more than happy to stay on the line and assist with additional questions or follow-up if you're interested. All right, at this time, I'll be passing the presentation over to Jason. Jason, if you want to say hello.
Good morning, Ben. Good morning, everybody. As Ben said, we're doing some color contour and process capability database for the webinar. So I'm going to jump into the model right here. So when we begin using color contour, we want to go ahead and on the visual toolbar, we have the color contour icons. Once we switch this on, CATIA will ask us to go ahead and switch into shading with material mode. This is going to be automatic, so when we just turn it on, we just hit the OK button. Now we're in shading with material. So now if I hit nominal build, you'll see that it starts with the color contour. Before we go into showing this visual awesomeness, a little bit about the preferences. We have all of our preferences here to show the legend, the precision as far as trailing zeros in the legend, the manual scale, the position, the font size, everything is pretty much located but extended away from the original 3DCS preferences. So now if we hit nominal build, we can see that we have a legend over here that shows deviation. Once I hit deviate, all of the color mapping or color contour will be going through all the steps, all the tolerances that are in the model. Slow it down for a little bit and then stop. So when we stop. So now, right now it's showing that the color contour is a little bit out of spec for around 2.31, and if we can see it visually at the top of the knuckle. If we can continue it, we can stop it again.
So just at this point, you can see that the legend is changing, where the maximum deviation is always going to be at the very top. So it's always going to be red when the legend is allowed to automatically change, right?
Okay. So, and then also to mention, like Ben said, right now we're showing the min and max values. The blue part will always show, blue and red will always show in a model. So I'm going to close this. I'm going to actually go back to our preferences, and then we can set the manual scale. So everything that I want to view is going to be within 1 and 1.5 of the max, min and max deviation.
So for example, oh, sorry. So with the
build.
Yeah. With the set scale, you know, if I want to, if it doesn't bother me when something's, you know, 1.2 or less, I can set it to be the manual scale. So it's only going to show red when it's over, you know, 1.3, 1.4, when it's actually going to be an issue, if I don't want to always see red on my model.
Correct. And as soon as I hit nominal build, you can already see it just went from 1 to 1.5, and if I start deviating, we'll only see a little bit of the actual model that is going to be within those 1.5 to 1. So now I'm going to show a simulation we already ran. And this is the little difference for a simulation. So if we,
Before you get into that, Jason, hold on a sec. Before you get into that, can you talk about the deviation direction?
Oh, sure. So while still in your model, you're just looking at it to deviate it, we can set the direction based on the measurement direction. So if we want to view all the deviations in X, we just activate the X direction and then deviate, and we'll be seeing all the deviations that are just in X. We can also go back to Y, X, or all three, or just one, rather show one.
So X, Y, or Z are the three options right now.
Correct.
Can't choose a custom direction.
And this is also the case for when you're running a simulation, so we have to go back in and out of this. We want to make sure that these are all on so we can view it. We also can show, while in a simulation, we can show out of spec, percent out of spec, standard deviation, PPK, and estimated range. So I'll switch it to percent out of spec. Bring up the simulation window. So now it's showing everything that is going to be, with all the measurements that are in this model, it's showing the highest that's out of spec and then the lowest. So if we go to the second tab, the second measurement, this is the measurement that is the highest out of spec, 46.3, and it is actually this measurement. It's a point measurement right on the wheel. So we scan through some of these measurements really quick. The legend is not going to change. It's already fixed to all the measurements that are in this model. But we can see within the model, when we scan through it, that the measurements will show the actual deviations or out of spec on the color on the part as well.
So this allows us to quickly identify, which areas are farthest out of spec.
Precisely.
Now, one thing
okay.
I can see here is that it looks like only the control arms are changing color. The wheel and the frame are not. Can I choose specific parts that I want to color contour, or do I have to do my whole model?
No, you can definitely do specific parts. We have to go into the DCS tree, and if we want to do specific parts, we right-click on a part, or we can right-click on the root and select Part Color Contour. This is to give us a list of all the parts that are in here. We can activate and deactivate specific ones. Right now they're all just numbers, so I don't know which one's which.
That would be something for Amy's display, right?
Yeah. So I can go through it and activate any of one of these or all of them to show.
So if I have a really large model, instead of waiting 3 days to do 10,000 parts, I can choose a sub-assembly and just color contour a sub-assembly. Okay.
So now that I have all the parts activated, now all my parts are color contour.
Gotcha.
Or now I'm just showing the base and a little bit of the knuckle.
Okay. Can I go positive, or I can go positive and negative in one direction when it comes to the actual color contour? That's the.
I'm sorry, can you?
So on the color contour, this is a question. Let's see if I can understand it correctly. Is there a way to differentiate between positive and negative deviation? I think if we set if we set like, yeah. So
there is
yeah,
no real way to. I'm sorry. There's no real way to go ahead and specify whether it's positive. It's just the nominal distance of that measurement to show the deviation.
Hey guys, this is Gary Bell. I'm sitting in here as well. The reason you do not get to define whether it's a positive or a negative is what we're doing is we're looking at the mesh nodes of any part that's defined for color contour, and we're just looking at the maximum deviation from that node from its design nominal in X, Y, or Z, or all three. So it doesn't know, if it's Z, if it's -2 and that's the maximum, then it's just going to be 2 and it'll be red.
Hey Gary, while you're on the line, can you follow up on that with so if I don't know the direction for deviation, is that going to be is there some way can I still make my corrections? Like if I don't know if it's going to be X, Y, or Z, do I just set all three and then?
Right. If you say all three, then it's going to color contour, and it'll whichever direction happened to be the maximum out. So if you pick all three, and one of the builds, Z, was out the farthest, then that will be color contoured red. The next build, if Y was the farthest out, then it'll use that for color contouring red. That's why we give you the ability, we give you the ability to have just X, Y, or Z, or all three. And then if you ran through some deviations and you wanted to get an actual number with directions, then where you saw something turning red all the time, I would just write a measurement there and run a simulation. Did that answer your question?
Yeah, I think that's good. Let's continue. I'm gonna follow up on the side here and try to get more clarification.
Thanks, Gary. All right, so we kind of want to step into a little bit of process capability database. The process capability database is essentially a database that we can build tolerances based on a customer standard. So if you, as a customer or a company that is building tolerances, all the time, you can use this tool to go ahead and create a library of all your tolerances. So I just went to the process capability database editor, and right now I already have a database already entered in. So we can go to this part here, and we can see that these tolerances have this little barrel on them. This is just telling me that it's linked to the database. So if I go into this pivot position vertical, down at the bottom it says it's linked to the pivot location up down. And also that sets its range and has all the points linked to it. So now if I go back to the database and open up this file, which is just a basic CSV file, we can change all these values or these names. We can set the value, the ±3 standard deviation value, the offset, the type nominal, the type name, the sigma number, any of these values, and it will show up in our model. So now if a database or the library changes at all, we can essentially just hit that same button, and I'm going to switch to another updated tolerances, load it into the database, and update all the database tolerances. So now if I go back into these tolerances, you can see some of them have changed. So this one was the actual 1 or 2. Now it's changed to a 0.2 with a negative 0.4 offset. It also became a little bit easier when you're creating tolerances that we can specify one or more points or features and create a new tolerance. So once we go ahead and I create the new tolerance, it shows up with this. This is a link to the actual database. So these filters, which are not filled in correctly for this database, these will be able to, you can sort through or add, whatever material that you're using, whatever feature type that you're using, or a process. We can fill these in and filter through. So if you have more than just the available 20 that I have here, you can filter through to the specific one, or there might be multiple in those filters. Then we can just add it. All the points are added into here. All the ranges are added or updated, and it's linked to the database. And again, if that value or the offset ever changes, we can just go back, load it, and update.
So just to reiterate, so I can take my points and I can link them to the process capability database, where I've got my predetermined manufacturing processes and tolerances for my material. So if I'm working with a specific thickness of aluminum or sheet steel, and I know what those tolerances are, I can put that in the process capability database so all of my modelers are using the same values for that particular material. And then if that changes, or we get a new machine or some kind of process update, I can just change it in the database, re-upload it, and it'll change all of my linked tolerances.
Absolutely. Yep. Absolutely. That file could be your one file that all your modelers or all the DCS modelers that would go to update. We can also apply it to all 3DCS tolerances, size tolerances as the link to the database, and we can also apply it to GD&T. So if we have GD&T on the model, there's one little limitation. We can still link it to the database. So if I wanted to add that, it's going to change that range, and then we can always just update it over and over and over again, or we can just link it back to the model. However, if we update this and we want to keep the database, so now it's got that little barrel on it, if we want to keep it to the database, we don't want to update the GD&T. That GD&T will erase whatever we have linked to the database. So there's a lot of goods and bads with it. We can keep the GD&T also linked to the database, or we can keep the GD&T just linked to the model if the model doesn't ever change.
Yeah, so you could start with like a process capability database linked GD&T list, and if something changes and you need to customize it on the fly, you can customize it. It'll unlink just that tolerance for that particular model. And then later on, if you want to relink it to the database, you can quickly do that as well, right?
Yes.
Yeah. So it means that your stuff's not, if you link it to the database, it's not frozen. You can still customize it. It'll just unlink it from the database.
Right. Mm-hmm. Yep. Yeah, you just need to go back to it, activate the flatness tolerance, and just link it back to the database. Going back to the process capability database really quick, I'm going to create a brand new one. And so we have a way that is set up in this editor to just manually go ahead and just really quick create a new database file. So I'm going to save it as an example. And then we can go into this CSV editor, and this would be our database, the actual database. So we just change all these the names for it, change the values to plus minus 3 standard deviation. We can add material type as far as like steel, plastic. One thing I did learn today is when we're adding these values, even in these columns, we also have to add them over here in the material types. So we have, I just added steel to our material, and in order for it to show up in our filter, we have to also add it up here in these 3 columns. So if we have a process like stamping, let's go down and copy them, feature type, surface, hole. We want to add these up here. And position and MMC don't need to be added. They're also integrated into this when we bring them into the database. So the 3DCS will know that it's a profile with group feature. It'll automatically create that in the feature tolerance. But we can also add the size if it's a size tolerance, just so that the tolerance knows what it's creating. So I'm going to save this file, go back into our model, and be able to show these filters when we're adding a new. So if we add these points to the new tolerance again, it'll actually show up as features that we actually added: the hole, the feet surface, a pen. There we go. So now I added the correct database to our model. We can go back into these points, add the feature tolerance, and then we'd be able to see the surface. So now it correctly will filter out whatever tolerances that are under surface, or if we wanted just steel, or if we wanted anything else like plastic or any other processes that we might have added into it. Now we can just select on it. It's already a group feature with profile with a crazy range. And we can always add more to it. It will be more filtered. We can add whatever we want to it. And this is also, it's also good to add, if anything, like plant data into the tolerance database if we're using QDM, or if we're adding standard tolerance, fitting tolerances, or anything, pretty much anything can go into the database and we can use it within that process capability database and link back to our model.
So if I get inspection outputs from like a measurement lab, or an inspection lab, I can actually use those as my process capability database to update my model, so I can swap in as built data very quickly from my simulation data, and then I can see an analysis on my actual as-built products rather than using estimated or historical tolerances.
Right.
Yeah, that's great.
And it's a pretty much endless possibility with the process capability database. There's a lot to add to it. We haven't added a standard way of doing it, but essentially add anything to that database file.
So
yeah,
I have a quick question. So is Gary still there?
I am.
Okay. All right. This is to both of you, so it's not just to Gary. So don't think that. But on the color mapping, this is kind of like a use case scenario. If I've got all 3 axes turned on, all right, and I'm running my color contour mapping, and I see my knuckle joint is dark red. So I'm obviously got a problem going on at the knuckle joint, right? So I've identified that as the trouble zone. I know. I had you changed all the parts and stuff because of that previous question. So now I've got your stuff all changed around. So if I get the knuckle joint that turns dark red and tells me that that's the problem area, how do I then determine which direction my issue is in? Which axis my primary deviation is happening in, so I can start adjusting or making changes to alleviate or control that variation.
Yeah. So one of the things that I would do is is you could run the deviation with just X on, and then it's color mapping based on just X variation or just Y variation, because you're correct in your understanding. Is if you deviate it and the knuckle point is red and you have X, Y, Z all checked, you don't know, which, what caused it to turn red. You could, if you had a point on that same area, you could do information point, and you could, check it from its nominal, and it would tell you, it's X, Y, Z variation.
Because I would see which direction the point moved in.
Correct.
Rather than just turning off Y or turning on just X and then turning on just Y, then turning on just Z.
Right. Right. So, I mean, you got to understand when you're deviating, when you're just deviating, it's looking at all the mesh nodes of the parts. So it's not collecting any data anyway. You can run a deviation and you get a visual and you see a certain area that's always red. Well, then if you run you write a measurement and run a simulation, then you'll know exactly what's happening. And then, then you get the color contoured lines, which is, what's displayed on the screen now, that can be, I forget what the settings were. He's got it displayed on percent out of spec. What else do you got?
Estimated range.
Yeah, so you could change that to estimated range. Probably got that. Yeah, there you go. And now at a visual glance, you can see that red line that's on the front wall of the tire. That's got the most variation, which is about 8.2. And then, then the top of the tire is green, somewhere around 4.10. This is now giving you a colored visual representation of your actual simulated measurements, which you can go into the physical measurement and get the complete results.
Well, while you're on that, Gary, actually, I got an extension on that same topic. So we're showing individual simulated builds, right, with our deviation. Is there a way for me to show an average across, say, if I make 2,000 simulations, can I show my average across that amount as a color map?
I'm not sure. Not sure if I understand that question. When you say average, our measurements, if you turned on, you got your mean. You got your mean, which would be the average.
Yeah, so would it be able to contour the mean? Do we have that option in there? Is that something that might be valuable?
No. It's something we should take note of, but it's not in there right now.
Okay.
So take a note of that.
Yeah. So here's a question for you. So on process capability database, so I'm adding process capability database tolerances to my model. Now I set my model down for a week and I pass it to somebody else, and they add a couple more from the process capability database and pass it back to me. Now I want to know all of my points that are linked to the process capability database, just so I know what's linked before I start changing anything. Because I know now that if I change something manually, it's going to unlink it from the database. So I want to know which of my points are linked to the process capability database and which are not.
All right. So if we go back to the process capability database, we can see, once I load it in here, let's go back. We can see all the tolerances that are linked back to the database. And at the top, it actually says inconsistent with database. So all these tolerances that I just added in here are not updated to the model is not updated to these new tolerances. So once I update it, it will update all tolerances that are in this model with the new database.
Is there a notation in my tree structure on whether something's linked to the database?
Yes. So if we go back into this part, the tolerance has like a little barrel or a little bucket. I don't know if you can see that very well. You can see it.
Oh, okay. So the
So
lower
it has a
left
little
hand.
barrel that's actually the same icon as the icon for the process capability database. It's just like a little drum barrel.
Okay. So
And then also, if you
go on.
go ahead.
No, you're showing what I want to see. Yeah, continue, please.
All right, so the other thing is that it also shows up in the tolerance itself that is linked to the database, and then that's the database name.
So there's three easy to find spots. One in the actual database icon when I hit the toolbar, right? And that shows my list, right? And tells me which ones have been updated and which ones haven't been updated to match the process capability database. All of my tolerances in my tree structure that have been linked have a link icon added onto their icon.
Yep.
And within the tolerances themselves, they also so
Yeah, right there.
if I didn't want to go, is there like an output or a report or anything like that, or like a view, or could I use like AAO or something to see which ones are linked?
Other than this, this is all we have. We also have the summary that just basically says the same thing.
Oh, okay. So there's a summary right there, and that
Yeah.
the summary will have. Oh, I see linked items in this model. So it should have a list of all of my linked items.
Yes.
Okay. All right. So how do I find that summary?
If you go back to the process capability database editor,
Uh-huh.
the summary button's on the bottom middle.
Okay. Click it again for me, please.
Yep.
All right. So with that one button, I can get a text output of all of my linked items in the model.
Yep.
Okay.
Yep. Shows the tolerance and then what's in the part.
All right. Sorry about my clicking.
All
right.
Okay, go ahead, Ben.
All right, so we're working in CATIA here, and as Jason mentioned, we do have a multi-CAD platform that works, with it's CAD neutral, so it works with NX files, CATIA files, SolidWorks, different CAD systems, and we also have, of course, the 3D Experience integrated version. Now, while we're in the CATIA version, since it's one of our integrated versions, if I have tolerances and FT&A in CATIA, and then I load my 3DCS in, I can of course pull all those tolerances over first to start, and then I can add the process capability database after that to either additional tolerances or update my existing FT&A and other tolerances with my process capability database.
Absolutely.
Okay.
When you're bringing that database or the actual DCS storage file back into CATIA, the database file will be linked within that file, the WTX. So it'll contain all these tolerances as well as the link to the database. So when you just import that DCS file right into CATIA, you'll have all your tolerances, your points, your GD&T, and then it'll be all linked to that same file for the database.
Okay.
And you can see with this model that the knuckle has been toleranced multiple different ways. It's toleranced using plant data, it's toleranced using FT&A, it's toleranced using DCS tolerances, and it's toleranced using the process capability database. You can mix and match all of that and what's available.
All right, so let's go back to color mapping. on color mapping, on setting it up and viewing, can you just summarize for us, please, on setting up and viewing?
You want to see how the parts are color mapped individually?
Just grab the 3 parts, the 2 control arms, and then the 2 knuckle, the knuckle assembly right there between the 2 of them. Do color mapping on those. Yep. And then while we're on this, when we're color mapping, what we're actually color mapping is our sensitivity output.
Yeah.
Right. So we've toleranced the model, right? And we've put measures on it already. And we've run a Monte Carlo simulation. So can you bring up that money? Yeah. I just want to kind of show everything you need to do this. What do you need to do a color map?
Okay, there's 2 types of color mapping. There's color mapping the contoured lines, which is based on the results. When you see the whole part color mapping, that is just based on the mesh nodes of the detailed part. It's deviation from nominal, X, Y, or Z, or both. So when you see a nominal build and the parts turn blue, no parts are going to color map in this one. Oh, there you go. So you can see here that there's 3 parts right now that will color map. And when he hits deviate, and if he just deviates 1 position and stops, okay, all that's doing now is color mapping those 3 parts based on their mesh nodes varying from their nominal. And the largest deviation will always be red. So in this one build, it looks like the shock. I don't know. I didn't know the shock. Oh, you color mapped the shock. The shock is the farthest out of position, 1.4 millimeters. I don't know if that's X, Y, or Z, but compared to the other 3 parts that are color mapped, they're within 0.72 or 0.84 of their nominal position. All you're getting here is a general view of the overall part when you hit deviate. When you run a simulation, you're not color mapping the parts at that point. You're getting the lines that pop up. And now at that point, those lines are trying to give you a visual understanding of your measurement results. And so there's 4 measurements on the front face of the tire. And the big red line is one of the measurements, and it happens to be 8.2 millimeters. So if he found that measurement, there's the 8.2. So now, instead of clicking through the measurements, he can just look at these color map lines and say, oh, that one's 8.2. The yellow one in the back is approximately, 6.6 maybe, or 5.75. And then you can go to any specific measurement and see the actual number, which is 5.49 or whatever. I can't see.
5.9.
Thanks. I don't have my glasses.
So all the measurements will be listed that are within the estimated range from the legend will be listed over. So we have ride height, which is not listed in here. But we can scan through this and find all these measurements, the 1.8.
Yeah.
Oh.
Angle measurements. Yeah. So is there still some confusion between the part color mapping and the actual simulation results color contour line?
No, I think that makes sense. One thing you did mention is you keep. So if I want, what do I need as a prerequisite to use this? What do I have to have set up on my model? Can you just briefly cover that?
Yeah, you basically just need to build the model as far as with points or features. Then you would have to add tolerances, and then the measurements to measure between those parts and tolerances. This will give you the color map variation or the visualization within your model. If you just have a measurement, you're not going to see any color map. It's not going to deviate. It's not going to deviate. If you have one tolerance,
you get one tolerance.
It'll still show. It'll color map that.
Right. If you have one tolerance and it's on a target point, and you have a move that's moving to that target point that's making the whole part shift, that part's going to color map.
Mm-hmm.
So to answer your question is any model that's got moves, tolerances, and measurements, you choose what part you want to be color mapped, and then when you do a nominal build and hit deviate, it will color map that part so that you can get a visual, of where the variation is on that part. I guess, actually, to answer your question, you don't have to have measurements for the part to color map because it's deviating, it's checking the mesh nodes from nominal. The only time you need measurements is for the color contoured lines because that's based on the actual simulation results. What do you do?
I got
tolerances off.
I got a quick question for you then, Gary. One thing you did mention is you kept saying that it's showing. Oh.
I'm sorry. Go ahead.
It's tied to the mesh nodes on the model, right?
Yes.
Now, the mesh nodes you're referring to are not, and I want to repeat, are not in reference to finite element analysis, FEA. That's correct?
That is correct.
Okay. They're talking about the features or the
mesh. Yeah, it's the mesh of the CATIA. If he goes to the, go ahead and separate your model and go to your pull down where you, what the heck is this called?
Yeah, our attendees they just want to know what it is they need to do to the model to get this going and what the requirements are, and want to make sure that it doesn't require like additional FEA mesh or add-ons or anything like that.
It requires moves and tolerances.
Yep,
that's
moves
it.
and tolerances.
And then for color contour lines, it requires moves, tolerances, and measurements, so that you can get simulation results.
Right.
And one nice thing about these two features is that they're built into the base 3DCS Variation Analyst software.
Correct. Everybody gets this for free.
Right. I just want to reiterate that this isn't an add-on. I didn't make a mistake this time and say that. So.
No.
Okay. So the deflection is only generated then from the move points and the tolerances on those move points. Does that make sense?
Yes.
So just moves and tolerances if you want to see the deviation, and then moves, tolerances, and measures if you want to see the simulation and the color contour lines.
If we showed triangular mesh, would we be able to see the nodes?
That's what I wanted him to do. I think it's a question. Yeah, I think that's it. Separate it.
Oh, okay.
So this is a great opportunity. So this is the mesh, and that's why if you notice we've been avoiding. Is that the mesh? No, it's the question mark, right? Question mark.
You want to see tessellated?
Yeah, I think that's it. There you go. So I believe this is what we're using, and that's why we avoided color mapping the tire. The mesh is so dense, the more parts you color map, the slower the system is going to get. But I believe this is the mesh that we use. The nodes of this mesh is what we use compared against its nominal to color map the part.
All right, that sounds good. I don't want to spend too much time on that particular aspect. I just want to make sure that was reiterated. So can you show me, so since we already have the moves and tolerances on this, can you show me the button specifically to set 3 parts or 4 parts to color map?
Yeah.
Again?
Yeah.
So I selected the parts in my part list.
Right. You select them, and then you can right click, and then you go to part color contour.
Okay. All right. Can you select that for me?
So this, it actually won't show up for all parts that I selected. It'll just show up for the first one I selected. So unfortunately, I would have to go to each one if I just wanted to show the tire, which I don't want to show.
Or if I want to show
Or
a couple
if I want to
parts.
go to the knuckle, I wanted to go here and say, turn this off, that I can just deactivate or activate. If I wanted to go to the spring or the shock, oops.
Yeah, just find it in the tree.
Go to the shock part and then hit part color contour. It'll show just that part. I can deactivate that. Or if I wanted to go to the subassembly, I can hit part color contour and it'll show all the parts within the subassembly. Or I can actually go to the root and show all parts in the whole assembly.
So this is where you choose what parts you want to color map. And this is where I was saying avoid parts that have a really high dense mesh. So anybody that's got a finished model, I'm pretty sure if you have a finished model and you hit the button, pull out the color the dialog, yeah. And you see that the top left button, that turns color mapping on and off. When you turn it on and you hit nominal build, any part that's going to be color mapped will turn blue. So when you start out, if you take any model that you have completed and you turn on color mapping, I'm pretty positive all your parts will turn blue. Because by default, we will color map everything until you go in and turn them off. So the first time I did this suspension, I just hit that button like he did a nominal build, the whole thing went blue, and then I hit deviate because I wanted it to color map. And it got kind of slow. But
That's
here, you know,
since
we're not color mapping the tire, you can see it's pretty fast. So the key is once you turn color mapping on, which is just that button, and then you do a nominal build, you see what's blue. If you want it to color map, great. If you don't, then you go into the tree and you right click on a specific part that you don't want to be color mapped and you deactivate it. Right there, right.
So now that upper
is deactivated, right? So now when he hits deviate from here, that's interesting. Yeah.
I just turned all the tolerances off. So all you're seeing is GD&T.
Oh, that explains it. So there's no assembly tolerances. All there is the GD&T on the knuckle. Okay.
All right. All right, thank you very much. Okay, we're about 50 minutes past the hour here. I know everybody has other meetings and things to get to today. So at this time, we're going to start wrapping things up. I do want to let everyone know that I will be sending the recording out. You should be receiving it tomorrow, late morning, after I have a chance to process it. I'll also be sending a link to the first part of the series. As we go through the series, I'll be keeping all of those links in the follow-up emails, so that way if you want to go back and reference a previous webinar, you will have access to that without having to send an additional. However, we can stay in the line for a couple more minutes for anyone who wants to ask some additional questions or see something specific, just in case there's some kind of any kind of confusion or if there's anything that didn't quite make sense on the first run through. So I want to thank everyone again for coming today. And like I said, you'll be receiving that email tomorrow early afternoon, late morning, with the link to the recording and a presentation to go along with it for you to review and use with your models. All right, so at this time, we're going to stay on and answer a couple more questions to take us just past the hour. Here's a quick question that came in. So if I ran 5,000 builds and I want to see my final simulation result, can you talk about that again? Because I know you mentioned that with the color map lines with my simulation data.
Oh, you know what? Yeah, so take this model here. He'll bring up and do a nominal build, though. That's right. Okay, so 5,000. Okay, this model only has, what, 2,000. So once you run your results and you have your color mapping turned on, you can see the color map lines pop up, and it shows you that tire, if you see the red line down at the bottom, so that's the measurement that's got the 8.2 millimeters of variation. Is that the measurement?
Yep. No.
So he's going to go to that measurement. From here, he can actually go to View, Show Max, and now notice how it color mapped the parts. Rotate that. Okay, it still didn't color map the tire, but it color mapped the knuckle based on its deviation from nominal that produced that 8.5 millimeters, or that, well, the max is not 8.2, the max is 4 millimeters. So go ahead and say show min. Okay, see how the knuckles color mapped differently than when you say show max? So once you run your simulation, you can take any of your measurements and put them into their max, min, mean position, and it'll color map, you know, all the rest of the parts based on where they are from their nominal that produced that measurement. I don't know what's going on with the floor knuckle.
Is this the GD&T still?
It should only show what is in the simulation.
Yeah, I mean, turn the color contour back on the upper knuckle, or upper control arm.
Oh.
Nominal build. It's not white, isn't it? Didn't turn blue.
Let's try.
Yeah, close all that. You sure you got the knuckle?
Ooh. Okay. Active.
No, the build.
There we go.
There you go. Now bring the results back. Oh. Separating nominal.
It's just showing the estimated range, and it's only going to show the color map lines.
No, it'll go into show max. There, there it happened. It was just a minor display. That upper knuckle, or the upper control arm, is color mapped. So when we took this measurement, said show max, you can see how it color mapped the upper control arm based on the position of that measurement being at its max. Are you on the right measurement? Yeah, you are. Show max, show min. Yeah. Perfect.
So you're gonna have to excuse me as the marketing guy here. In your sensitivity analysis, in your outputs, I see the standard deviation of 1.37 millimeters across Six Sigma. Do you see what I'm looking at?
Yeah.
Yeah.
Can I? Is that showing my range? Or what is that?
No, your range is 8.2.
Right. So
that's
what
the
is
Six Sigma?
All right. So can I show my Six Sigma?
In color mapping?
Yeah.
Well, Six Sigma is the effect of that measurement going to its maximum and its minimum. That's, if you look at the histogram, you can see the histogram plus 3 standard deviations is around 4. Minus 3 standard deviations is also minus 4. So we can color map the parts based on their deviation, but I can't put the part at both minus 4 and plus 4 at the same time. So my range of variation is 8.2. I can tell the computer, okay, put it at the minus 4. That's what he was doing when he said view show min. And it will shift the position of all the parts to the position that produced that minus 4. Did you do it?
Yeah.
Oh, okay, then show max, right. So I can't color map the range. I'm color mapping the part based on its maximum deviation from nominal, and I can put the part itself in any position produced from the simulation, min, max. I can put it at 1 standard deviation, 2 standard deviation. When he goes up there and he says view again, if I say show sigma, okay, now I can put it at any position I want, 2 sigma, 3 sigma, 4 sigma, but it can only be plus 2 sigma or minus 2 sigma, and then it color maps the parts based on that position of the build. To answer your question, color map the range. I can color contour line the range, but the parts are being color mapped based on their position, any one position. And that one position can be the max or the min, or anywhere in between.
All right. I appreciate you going through that, Gary. Thank you.
I hope it helped.
Yeah. All right. So that was all the questions that I had lined up for our Q&A. I'm going to put us on mute for just 2 or 3 more minutes in case anyone has a final question before we sign off for today. Once again, I want to thank everyone for coming. We had guests in from the United Kingdom, from India, from China, from the West Coast, the East Coast of the United States. I believe we had some guests from Canada as well. And I hope I didn't miss anyone there, but I really appreciate everyone signing on and joining us from all across the world. We appreciate your attendance. Oh, I see we had some guests from Brazil and Germany as well. So thank you so much for joining us today. Like I said, we will be sending the recording out with the previous part of our 7320 series. If you have any other questions, please feel free to send me an email or reply back to that recording email that I send out tomorrow, and I'd be happy to either set you up with one of our IT people or to answer your question as best I can. So once again, thank you so much for joining us today. We really appreciate your interest and your attendance.